Technology will not save the world, but we will not save the world without technology. Each month, Objectif 2050 explores innovations for the environment and the world of tomorrow. A special series of Digital World in partnership with EDF, a major player in the energy transition.
We can measure the temperature level in real time, relative humidity, CO2, the CO2 level, and the algorithm is able to analyze all these elements in real time to control air conditioning and heating in buildings.
Buildings around the world consume 40% of the world's energy by themselves. To reduce this energy and environmental footprint, one solution is to make them smart. That is, able to better manage their energy needs in real time. That's what the Italian startup Enerbrain is doing, backed by them, who has developed its own connected devices, sensors of all kinds, and cloud programs to make these buildings a little less food lovers. Explanation by Alberto Riboni, sales manager for France and the United Kingdom at Enerbrain.
Since 2015, we started developing our optimization system. Smart algorithms, cloud-based, that can be connected on the field with existing objects. So with connected objects in the buildings we construct, understand in our platform to control and optimize them remotely. So apply a layer of intelligence to work to make the existing elements in the buildings work better.
In what type of building do you install your solutions?
So it's very interesting because the flexibility of our technical solution allows us to work with more types of buildings, with many different types of buildings. We can work mainly with, I would say, complex buildings from an infrastructure point of view. So large retail stores, whether it is public buildings such as hospitals or schools, university campuses, but also in the service sector, meaning large buildings, company headquarters, like those of defense, for example. So really the ability we have is to adapt to what we find located in the field and therefore able to offer our solution to different types of buildings. Here in the Paris region, once again, we have a very important example for us. We work with a hospital, a very well-known hospital, which is GHU Santana, in which we have integrated a case, the antenna of their building. And we are helping them to optimize, to lower their energy bills.
So sensors, temperature, etc. What is the implemented system?
There are several ways to integrate our solution. The simplest way is to create an ecosystem of connected objects. So we decided to produce our own catalog of objects. So yes, as you said, there are sensors, indoor air quality. We can measure the temperature level in real time. Relative humidity, CO2, the rate of CO2. So we will assess human presence in rooms, offices, and spaces. And all this allows us to relay this information in real time. So our sensors send information to the cloud. And the analysis done by the algorithm allows it to send back to actuators, always from our productive design, the necessary information to better manage the operation, for example, of boilers, rather than grass treatment plants. So real elements, real equipment, who produce and distribute air conditioning and heating in buildings.
So, there's a hardware aspect and also software, of course, you need intelligence. Do you specifically use artificial intelligence?
So, artificial intelligence, yes and no. I would say it's more what we call intelligent algorithms. We prefer to present our solution like this. These are algorithms that are, once again, as I said, cloud-based. They're based in the cloud and in the brain, and collects and analyzes all elements, measurements, and variables, several aspects of the daily life of the building, and the algorithm is capable of analyzing all these elements in real time to control, to send set points, actuation points of verb, shareholders in the field. So we obviously need to know what our clients' wishes are, such as the desired temperature set points in a building, the desired comfort for the occupants. We take external data into account, including everything related to weather, obviously the changes in external conditions of our places where we work on the capacity, I mean the way the building works. So there is a part we call the algorithms self-learning, which by analyzing all the historical data collected day after day can anticipate certain decisions compared to the needs of the next day, the same day, the coming hours, compared to the actual occupancy level of the building.
Smart buildings are a concept that's actually not that new, but I imagine it has made a lot of progress. What are the recent technological advancements in this field?
So it's true. It is still a topic that has been on the table for a few years now. The continuous evolution we have seen since 2015 on our plan, own solutions, an internal research and development team at Enerbrain that continues to advance, on one hand, the hardware side, meaning the technical objects, technically evolving with new, new capabilities, new possibilities, but also the algorithm part. So we have a team dedicated to developing the algorithm part, meaning the possibility to increasingly use data collected by the building to be even more efficient, more oriented towards very fine management, 7 days a week, 24 hours a day, which sets us apart a bit from the use of a standard BMS, a typical building control system of a standard BMS. And with a fixed schedule or flexible calendar. And that's it. Something that brings the solution to a very interesting future, because on the other hand, the algorithm can make decisions every 5 minutes and thus evolve constantly. It continues day after day, really the functioning of the building. That's what makes us a bit more pushing to make the building we work on even smarter, as we used to say.
What are the benefits of these solutions? How truly can you quantify the benefits?
We can demonstrate, and we have demonstrated with several references we currently have, results that can be around a 15-20% reduction in consumption. Compared to an initial situation before we arrived on site, you can consider that right now, from 2015 until now, our platform, the Enerbrain solution, where all the buildings we have connected are available, now contains more than 700 buildings. Which means that at a global level now, because we work in 13 different markets globally, so on deuxième occupan, on la connexion, there are buildings that are connected to our intelligence, to our cloud Enerbrain, and it's starting to become a significant number, and it obviously helps us when talking to people. I'm awesome as to make this tool interesting and powerful.
Can what you learn about certain buildings be useful for others?
So, obviously, these remain reference data for us. Obviously, there are all the topics of privacy, data, avoiding sharing data between different clients and partners. But for us, it's clear that it's experience. For our teams, it helps us gain a lot of experience of terms, comparisons, and what we call key performance indicators in English, in any case, are points of analysis by type of building. It obviously helps us to make a comparative analysis and to see groupings by type of base, which allows us to have reference data and an idea of what else we can do. Once again, by type of bit or by vertical on which you can work.
So, this is a solution that can be installed in existing buildings. We don't have to start with a new building.
So that's absolutely it. And above all, it's kind of the point of the solution. Our idea from the beginning is to attend to help our partners work better what they've already done in their building. We are not an engineering company, so we are not interested in providing studies. Renewal of installations, we really want to make existing things work better for our clients. The idea, the interest, the flexibility of the urban solution, of the urban system, is to be able to in the buildings in which we work, to make them work best, thus optimizing them. We really want to have a budget to propose an accessible solution. It's a reasonable investment, but one that can immediately bring concrete results. The installation time, the time needed to integrate it into this solution. This is done in a few days. We're not talking about 2 months of installation. We're really talking about a few days, 1 week of installation for buildings like this. That means that right after the system is online, it is collecting data and it starts right away, the possibility of optimizing the systems. So that's also the interest. It is really, really It's the ability to implement the solution as quickly as possible.
You talked about the financial benefits in terms of saving on electrical bills, also energy bills. But in terms of the environment, CO2 emissions, and so on, there is also a tangible benefit.
It's connected, it's directly connected. The fact that we avoid consuming energy can be transformed or something as an equivalent to over 2. So obviously it helps the decarbonization process, our clients. That's it. We are part of the solution. We offer our approach precisely to help the client in its own decarbonization strategy. And so part of it, obviously, is directly linked to reducing utility consumption. So absolutely, we are able to quantify and explain to the client the positive impact of the solution. Also in terms of tons of CO2.
What do you think the future is? What directions do you think you'll go in? Are there technological improvements that you are already working on and that could really bring even more value?
So, surely, there is a continuous evolution of everything which is basically a technical subject. The hardware part, the materials, the objects. For ourselves, if you think from 2015 until now, our air quality sensor evolved into 4 different versions. So we're now at what we call version 4. The importance is obviously on our side too, to be able to limit the need to use the internal battery. So to lower lead to the need for consumption for our objects, the required power, and the ability to communicate more easily with networks like LoRa and Sigfox. So these are all solutions that we have. It has evolved in our category of objects since the beginning. So it will surely lead us to find new ways to communicate and transmit data in the cloud. And that's one thing. The other aspect I see is really the ability to integrated into buildings, into existing building management systems, whether they are old systems with decades of life. Live with the new system as well, but to be able push even further and facilitate even more integration into buildings.
You're talking about the battery. What does that mean? There are self-powered sensors which would need to be recharged, etc. Isn't that a bit inconvenient?
No, on the contrary. The advantage of our sensors is that they are sensors that can be easily moved. They don't need to be wired. So these are small sensors, 10 cm by 10 cm, that have a rechargeable battery. The battery is simply rechargeable. But the lifespan of batteries is between 3 and 4 years. Consider those who have data transmission to the cloud every 10 minutes, which means 140 messages per day per capital. So the power, and again, it depends on our client's needs. We can limit the number of transmitted data, and it will obviously show up. Battery lifespan exists. The choice we made, however, at the first sensor precisely, is to move more and more towards rechargeable batteries, thus limiting the impact of changing the sensor or changing the battery. And we're really talking about 2015 is the first wave version. Now we have chargers that have a lifespan 20 years or more in terms of internal technology, and simply by recharging the battery every 4 years.
Which means that today, even old buildings can improve their energy and environmental impact.
It's just like that. I will show you an example. We can pass in the context from the establishment of Sainte-Anne University Hospital in Paris. Some of the pavilions date back to 1800. It is a truly historic establishment in the city of Paris. The 20 or so buildings that we have connected, there isn't one with the same characteristics, not in terms of the building, not if we talk about the early days. Internal distributions and infrastructures, there are really very old pavilions, so the benefit is being able to work. And also for these buildings, to really make buildings that are initially smarter, are not supposed to or do not have the ability to be connected. So that's also what a lot for our solution, which is very popular. To our customers, it's the ability to really work on different types of buildings with very, very, very variable characteristics.
Thank you, Alberto Riboni, Sales Manager for France and the UK, Great Britain of Enerbrain.
Thanks, Jérôme, for this invitation.
That's it for this episode of Objectif 2050, a special series of Digital World in partnership with EDF. Find all the episodes on all podcast platforms, on the Numérique YouTube channel and on their website. Website mondenumérique.info.